Hey everybody, in this video we are going to port our TCP blocking socket project to be able to support Linux. We're going to try to do this all in one video, so the video might be a little bit long, but we'll see how it goes. Let's open up Firefox and go to our GitHub repo so that we can download it. Alright, so we are going to go to the last branch we had done for the TCP blocking, which was tutorial 17. And hit download zip. And now that we have this zip file, we are just going to go ahead and extract it. Now we have this little setup right here. I'm going to move the extracted folder to the desktop. And what we're going to do is going to rename that to pnet. Inside of this folder, we have our pnet folder that has like our, all our source files. I'm going to rename the pnet folder for this to source. I'm going to add a new folder called build. Once we've created the build folder, we're going to go ahead and open up VS Code and open up the source folder. Now we have our source folder available with our server, our client, and pnet. Now if we go to our source, you'll see it doesn't recognize the pnet include me. There's two reasons. First reason is we're going to go into our configuration help. We are going to change the include path in our CPP properties to be the workspace root. And then if we go back to our source.cpp, I had used a backslash here, and I'm surprised that worked. But we need to use a /. And in the client CPP, same thing. Should have used a / here. Now what we're going to do is inside of our source folder, let's go ahead and make our CMake list file. So we're going to create a new file, call it cmakelist.txt, and let's move that up to the source. For our CMake file, there are a few things that we're going to do. We're going to set the minimum version required to just be whatever we're using. I think we were using 3.1 or 3.10.2 or something. We're going to set the name of our project. This is going to be for pnet and the server and the client. And then set our version. And then we are going to set our include directories. CMake is going to be inside of our source folder. So by using the CMake current source dir, it will capture the pnet include directory. And it would also capture client and server for whenever you add headers to that. Next, we need to set up the executable for the server. So we will just call add executable, have our server, have the main source code file for the server, and then have all of the headers and CPPs that it needs to access. From what I understand, I think you don't actually have to specify all of these headers, but it's good so whenever somebody creates this project with CMake, these headers should be pulled into the project. Now we're going to do the same thing for the client, so I'm just going to copy that and paste it and just change it from server to client. And the last thing is when I build these, I want the binary file to be generated inside of the bin folder, which will be inside of the build folder. So what I'm going to do is I'm going to call set target properties inside of CMake and set the output directory to be the build folder, because I'm going to run this from the build folder, and then inside of the bin folder. So it should put both of these inside of the bin folder there. Going to go ahead and save this and open up a terminal. And if we go to our build folder, I'm going to create a shell script for compiling this. So I'm using vim for the text editor for this, and I'll call it compile.sh. What we will do is we will be in the build folder when this runs, so we are going to call CMake, and we need to go up 2 folders and then go down to source. So we're going to call CMake on source, and then that will generate the make file. And we're just going to call make. And that should be all that we have to do here. So to save in Vim, we're going to hit escape. and then hit hold shift and hit the colon. And then down here, we can hit exit. It's kind of weird, but now when we hit ls, we'll see the compile.sh file. So to run that compile shell, we can do, /compile.sh, and we get permission denied. We need to mark this file as an executable with the chmod command. So do chmod +x compile.sh. And now, when we try to run it, it actually runs it. But of course we get errors since none of this code has been ported. I'm going to go ahead and close this terminal and just work from VS Code. What let's do actually is inside of the terminal, let's go and run that compile shell. So we're going to go up a directory, go down to build, and run the compile shell script. And what that will let us do is when we get these errors, we can hold left control and click on them, and it will take us straight to it. So the issue right here is we are trying to include the WinSock header, but that doesn't exist. So what we'll do is we'll say if def win32, so if we're on Windows, then we'll do this stuff, otherwise we won't. So we need to save that, and then we run the shell script again, and then we get, okay, socket handle also has this. So we need to do the same thing here. And something else is you'll see, okay, well now we're going to have an error where socket was, because we don't have that type defined. If we're on Windows, we need to include WinSock to pull on this socket type. However, on Linux, we'll just use integers for the socket handles. Now let's run this again. Now we have another WinSock header inside of IP endpoint, ws2 TCP IP. Of course, now we have some errors because of the fact that, we go down, we are missing the headers for sockadder, sockadder n, sockadder n6. So what we'll do is we will have to include a header called inet and a header called netdb, and that should cover the errors that we were going to get in this header. Now inside of packet header, we have another WinSock header include issue to address this. And really in the packet header, we're only using WinSock for the host to network long and host to network short conversions. So in Linux, that's what we're using inet for. Let's go ahead and try to compile again, see what we get this time. All right, so now it's saying when we call socket, the default argument for parameter 2 is undefined. So if we go to socket header, we have invalid socket for our default socket handle. Now if we go back to Visual Studio, what we'll see is the value for invalid socket is the bitwise complement of 0. This will be the largest value possible. What we're going to do is we're just going to do the same thing there, but we're just going to have to define this in our constants header. So we'll go up to the constants header, we will do. Now let's compile that again. And now we have an issue that bool is not declared. Well, a boolean with the all caps was, I think we were getting from WinSock or something, and it's pretty much just an integer because I guess they wanted to use 4 bytes for a boolean. I'm not really sure what the deal was with that. So we're just going to do a type def here. We'll save that. We'll compile again. We are getting errors about memcopy in the IP endpoint, CPP. So what we need to do if we want to access the memcopy function is we need to include one of the C string libraries. So we could either do that with cstring.h or string.h. It has to be one of the C versions of the string libraries though. So I'm just going to include string.h here to address not being able to access memcopy. Another thing is we were using ulongs here. However, ulong is actually like a Windows specific thing. So if we look at what ulong is in Windows, we'll see, oh, okay, it's just an unsigned long. So really, I can just use a 32-bit unsigned integer for this situation, and this should be fine. So I'm going to do a Control H to find and replace. I'm going to replace ulong with uint32t. Do a replace all. Alright, the next issue we can already see on the screen is it says, oh, the inAdder struct doesn't have an like a union member. So we say, okay, well, what does it have? And if we look, we can just use IntelliSense for this. We see that we have access to something called sadder underscore. So it's like, that's confusing. Why is it so much different than Windows? And what we can see on Windows, if we're looking at an inAdder struct, is we can only access the union, it looks like, but there's actually a macro, and it expands out to be that 32-bit address, and it matches the same name as the Linux name. So we can just use this lowercase version to match between both of them. Let's do a copy, and we'll do a replace all, and replace that with the lowercase sadder. Alright, let's do another compile, see what we get this time. So now we have the issue that in the IN6 adder, there is no union that starts with U. So if we look at this, we say, okay, well, although we have a union, but it has a different name, which is annoying. And it's pretty much the same thing. If we look at this same struct in Visual Studio, they both just are built up with unions. The only difference is the Linux version has one more type it can expand to in the union. But regardless, they both take up 16 bytes. So we can just start copying at the address of this struct and not even pass the union in. So instead of, putting .u or .in6u, we can just pass in the address, and that will address the problem there. Alright, so now we are having issues in network CPP. So for Windows, when we initialize a network and shut it down, we have to call these WinSock API functions. However, in Linux, you actually don't have to do this at all. So we'll just wrap a Win32 if def around this. Alright, and let's compile that. Making progress, but still have a few more things. Let's go to the socket CPP. We'll see, we can't find TCP no delay. If we go up to our socket header, the issue here is that the socket header is getting WinSock from one of these other includes that it has. I believe the IP endpoint. So let's just go and add what we need to the IP endpoint header. What we're going to do is we need to add 3 more includes for the socket and for TCP. So we're just going to put those in there. And then when we try to compile again, we shouldn't be getting that TCP no delay thing. But now we're getting errors about WSA get last error. Now there's a couple things that we need to fix with this socket CPP, so let's just address them all at once. The first is WSA get last error isn't a thing in Linux. In Linux, they will get the error by accessing a variable called error_no. Another thing is there is no define for socket error, so we'll have to add in a const expression or something for that. And the last thing is there is no close socket. I had to look around a bit to find it, but you'll see in our socket close function, we are calling close socket, but there is no close socket in Linux. Linux treats everything like a file descriptor, so we would just use close instead of close socket. So I'm just going to address all of these with defines because I am pretty lazy. So let's go up to the constants header and address these problems there. First off, socket error should be -1. Also, these things should only be happening if we are not in Windows. So if not defined Windows 32. Let's go ahead and fix that. I want to add in defines for WSA get last error and for close socket. So pretty much anywhere we have WSA get last error, it will be replaced with error_no, and anywhere we have close socket, it will be replaced with close. Now when we try to compile this, we shouldn't get errors about those specifically, but if you scroll up a bit, you should see that we are getting errors about false and about true in all caps. We don't see the true one, but we see the false one. These were meant to be used with the integer version of bool, and false is we're just going to have a constant integer set to 0, and true will have a constant integer set to 1. We also have an error in socket CPP, and it's complaining about converting the last argument for accept, which it expects a sock lane type, and we pass in an integer. So we're just going to have to put in an if-def block here. So for Windows, we will use the integer. And for Linux, we will use this sock lane t variable. And we also need to scroll down and do this when we try to accept an Internet Protocol version 6 connection. So we're just going to replace this line. Okay, and let's compile again. Close was not declared in this scope. We need to include a header to access that. So we need to include uni.std.h, I believe. And let's compile again. Okay, and now we are getting down to our client source file. So it's saying sleep was not declared in this scope. Sleep is not declared, but there is something called usleep, which stands for microsleep. So, sleep sleeps in milliseconds, microsleep sleeps in microseconds, and there's 1,000 microseconds in 1 millisecond. So what we can do is we can include that same header that had the close function in it. It also has usleep. We can just put in a define here, just for now. And we'll say define sleep, and we will call usleep. We will just pass in the duration times 1,000, so it should pretty much work the same. Let's run the compile shell script, and we built the client, and we built the server. So there's one more thing I want to fix, and this was just an oversight. If we go into the socket CPP, and we look at where we are sending and receiving, I was using null for the last argument, where you can pass in your bitwise ORed flags. Really, this should be 0 because it's not a pointer. And then for receive, we scroll down. I was doing the same thing there. I had null. It really should just be 0. Compile this again. Let's see if we got rid of all those warnings. The only warnings we get are going to be about the weird defines that I did. So it says that they built. But do they work? Well, let's test out the client first. So we're going to go into the client source file. Okay, we're trying to connect with an IPv6 connection, and we're trying to connect to the local host. Inside of my server for the Windows version, I've set it to listen on localhost for Internet Protocol version 6. So I'll go ahead and run this. And then I'll go back into Linux. I am going to go to my bin folder where these projects are. I'm going to run the client. You see what I get is the socket was created, but it failed to connect to the server. Now there are a couple reasons. The VM does not see my computer as the same local host, really. We have to pass in my local IPv6 address if I want to connect with IPv6. So I would put in my IPv6 address here, and then when I go up, I need to recompile this. So I went up to the build folder, I'm running the shell script. Now I'm going to go back into bin, and I'm going to run the client. You see, we still get that we could not connect. I feel like part of the reason that it's not able to connect using Internet Protocol version 6 has something to do with the virtual machine that I'm running this through. But what we can do is we can actually change this to use Internet Protocol version 4 and use my local IPv4 address, and we can connect that way. So I will recompile. Let's rerun the server. So now our Windows server is listening, And let's run our client on Linux, and you see we are sending chunks of data, and on Windows we are getting all that data. Now, what about a server hosting on Linux? Well, let's go into our server source.cpp. It is currently trying to host on Internet Protocol version 6. I'm just going to change that to version 4 and just listen on all IP addresses, because I'm not sure if this virtual machine really supports version 6 in the way it should. So let's recompile this, and let's go to run this server. And we see server successfully created and listening on port 4790. But when I go to the Windows client, let's see, am I able to connect? We're going to go to start new instance. Alright, and we get failed to connect to server. Now, this problem is not anything inside of the code, but it is actually, I'm going to do Control-C to end that program on Linux in the terminal. The problem here is in my virtual machine. So my virtual machine doesn't know that it should be able to listen on, port 4790. So I need to forward the port in the virtual machine. So we'll go to Devices, Network Settings, and go to Advanced. We're going to select Port Forwarding, and we're going to add a new entry. It's going to be for port 4790, 4790. We'll press OK. OK. And we are going to just run the server again, and go back to Windows and run the client again. You see, we connected now. We are sending chunks of data, and on Linux, we are getting those chunks of data. So yeah, that's pretty much how you port what we had into Linux. I'm going to have a link in the description to the GitHub repo with the CMake file and all of this stuff. So it should be really easy for you to get it running. Thanks everybody for watching, and next what we are going to do is we're going to be starting the TCP non-blocking WinSock series. And that will allow us to handle a ton of connections in a single thread, be able to receive and send data and accept connections all in one thread, and it's going to be a lot smoother.